Hello class, welcome to another lecture. Today we're going through section 6.3 called inverse trig functions. And here's the idea. We want to do, or we want to combine trig with inverses. So remember what inverses were. They are functions that just do the opposite of the original function. So if f of 6 is like 10, then the inverse is called f to the negative 1, and it just does the opposite. So we want to look at inverse trig functions. So we want to look at what's the inverse or opposite if your function is like sine of x. And then we'll do cosine and tangent. So the idea is that sine you should think about as you put angles into it, and then what comes out is numbers. So for example, like sine of pi over 4, hopefully you know by now, square root 2 over 2. So we have this angle that we input, and then we have this, not just a number really, but actually a height or a y value. And that comes from drawing the whole circle thing and doing this little process here where we say, there's my angle, pi over 4, and then my y value is root 2 over 2, and that's why sine of pi over 4 is root 2 over 2. So then, the inverse function, which we're going to write this with a sign and the little negative 1 here, so the inverse, what should it do? Well, it's supposed to do the opposite. So what it should do is it should ask or have a number plugged into it, but really like a y value or a height. And then the angle that gave you that height should be the answer. So we should have something like this. Right? Oh, sorry, not pi over 6, pi over 4, because it's just doing the opposite of whatever sine did to pi over 4. So that's how inverses work. So that's how it should work for trig functions too. So then, like, what about sine inverse of 1/2? What should that be? Well, now we're asking, what angle makes the height be a half? So what angle is that? On the unit circle, that's the lower angle, pi over 6. That makes the y value be a half. So sine inverse of a half should be pi over 6. But right here, at this point, you might have noticed an issue, which is there's actually another angle. There's a whole nother angle that when I plug it in, I also get a half. So this angle over here, that's like the corresponding one, it also gets me 1/2 for the y value. So why not say that sine inverse of a half, the opposite of plugging in 5 pi over 6 and getting a half, should be that I get, when I plug in a half to the inverse, I should get 5 pi over 6. So why not this? Right? Because they both angles, pi over 6 and 5 pi over 6, give you a half. So if I undo a half, if I do the inverse, shouldn't I get both? Well, then it's not a function if you have two answers. So functions never have two answers. So we have to decide. And it is arbitrary, but once we fix a decision, it has to always be the same decision. You can't change it. So what we're going to do is notice that if I'm asking for sine inverse of something, then the two answers are always going to correspond to the left and the right. Because, for example, I could be looking at sine inverse of this height. So this is really the height. And then I'll have two angles that give me that height. Or I could be looking at a different height, maybe down here, this green height here, and then there's two other angles that also give me that height there. So what we're going to do is we're just going to, instead of saying that both answers are correct, we have to pick one to make it be a function. We're always going to pick these answers. So we're always going to pick the angles on this side. But we're also going to pick the ones that go from negative pi over 2 to pi over 2. So we're really thinking about it as this half starting at the bottom angle being negative pi over 2 and then going up to the top being pi over 2. So it seems a bit complicated, but let's just do some examples real quick. So if I say like, what's sine inverse of negative root 2 over 2? So what I'm looking at is what angle makes the height be negative root 2 over 2? And there are two answers, of course. Actually, there's infinitely many answers to that question, but we just want to pick this one. We always pick the one on the right that goes from negative pi over 2 to pi over 2. So what is that going to be? Well, I know that it looks sort of like pi over 4, but it's this one down here, and it's going in the negative rotation. So it's actually negative pi over 4. And so the answer is negative pi over 4. So I just always pick the one on the right between negative pi over 2 and pi over 2. Another example we could do, what about sine inverse of negative root 3 over 2? So now, same thing. I'm looking at what angle gives me the height of negative root 3 over 2, the y value. Well, it's this angle here, and also this angle, but same idea. We pick this one, and we rotate this way instead of around. So what we get is negative pi over 3 rather than 5 pi over 3 if you go around the other way. So the answer is just negative pi over 3. That's it. So that's how sine works. So what about cosine? What about cosine? Same idea, but we think about cosine as eating angles, and then what comes out is x values, or left and right amount. So cosine inverse will do the opposite. And so now that's the idea. So let's just jump into the example. So let's say like find cosine inverse of a half. So now what we're doing is we're looking at the x value. We're thinking of 1/2 as an x value. So I don't know, there's about a half is maybe right there. So now we're looking at what angle gives us 1/2 for the x value. Well, there's this angle and this angle. So again, the same thing is going to happen. We're going to have two answers for every x value that you can think of, pretty much. So what angle is this? Pi over 3. And then down here would be negative pi over 3 or 5 pi over 3 if you want, depending on how you rotate. Well, this time we're going to pick this one. So the answer is going to be pi over 3. And what's going to happen is that for any other x value that you decide, so maybe if you pick this x value here, you're always going to get two answers or two possible angles that give you that x value, and we're just always going to pick the top one. Okay, so for cosine inverse of x, I always use the top angle, which is from 0 to pi. So the top angle where we think about rotating this way, from 0 to pi. There's a baby crying outside. I hope you can't hear it. It's really annoying. Okay, so let's do another example. Cosine inverse of, how about negative root 2 over 2? So again, same idea. I think of negative root 2 over 2 as an x value, and I ask what angle gives me that x value there. And that's going to be a pi over 4 type angle. So it's going to be 3 pi over 4. And that's what gives me this x value. So the answer is 3 pi over 4. So cosine, you always pick the top. Okay, let's do one more for cosine. Cosine inverse of, I don't know, let's do negative 1/2. So now I'm looking at negative 1/2 as my x value. And what angle is this here? That is 2 pi over 3. So it matches this pi over 3 here. So the answer is 2 pi over 3. Okay, so doing the inverse is really just thinking backwards. So the answers should always be pretty quick. You're just thinking about what angle gives you that x value. That's the whole idea, is you're just thinking about this question. What x or y value, depending on if you're doing cosine or sine, gives you, or sorry, what angle gives you this, and then it's either an x or y value, depending on if you're doing sine or cosine. But you're always thinking about this question. You look at this and you say, what angle gives me negative 1/2 for x values? Oh, it's this angle. That's the answer. So that's it. And then the next one is tangent. So for tangent inverse, I'll just skip a bit and just tell you that we're always going to pick the same way we do for sine. So we're always going to pick the angle on the right side. So same thing as over here. So if I say, what angle gives you tangent to be 1, that one's kind of harder because now this is really a ratio. So it's harder to imagine. What angle makes tangent be 1? Well, that one I just happen to know that x and y are the same at pi over 4, and so they cancel out when you do y over x. So if you do this over this, you get 1, and so pi over 4 is your answer. Okay, so tangent we're not going to do too much of, so don't worry about it too much, I'd say. Instead, let's sort of kick it up a notch a little bit, try to think of something a little bit more difficult to work on. So now we could do things like this. What is sine inverse of cosine of 13 pi over 6? This is just a slight complication of what we just did. So the idea is work on the inside first on this type of problem. Meaning, okay, I know where 13 pi over 6 is. It's actually right here. If I go all the way around, that'll be 13 pi over 6 if I count it out. So cosine is root 3 over 2. So that means that the inside just becomes root 3 over 2. And so now I've progressed on the question, and I'm asking what angle makes the height be root 3 over 2 now? That's the answer to this next part. So what angle is that? That's pi over 3. So first I'd go from angle, I plug in an angle, I get a number. Then I do the inverse, which means I plug in a number and I get an angle as an answer. Okay, so let's do another one like that. So what about cosine inverse of sine of negative 11 pi over 4? Same idea, work on the inside out. So first of all, where the heck is negative 11 pi over 4? Well, if I go around, that gets me to negative 8 pi over 4. So then this would be 9, 10, 11. Right here would be negative 11 pi over 4. So what is the x and y value there? Well, what's the y value that matters here? It's going to be negative root 2 over 2. And now I'm asking for what angle gives me an x value of negative root 2 over 2. Well, this angle already did that, but that's not the answer, because I always look at cosine, I always look at the top angle, so I want this one instead. So it's not just back to negative 11 pi over 4, instead it's 3 pi over 4. So you're always looking for the top angle. Okay, so that's the next type of problem. There'll be a couple of those on homework too. And then the most interesting types of problems are these ones. Oops. We're not yet the most interesting, but we're getting there. Okay, so next is something like this. So now we're going to do the inverse on the inside and the not inverse on the outside. And it's a bit tricky because this is not one of those good numbers like 1/2 root 2 over 2 or root 3 over 2, where you just know what angle the angle that gives you that x value. So it's a bit trickier because what's going on now is I have my x value is 4/5, and I don't really know what angle this is. So I can't just do that like the previous problems. But this sort of hints at what to do instead. So instead we do this. So the basic premise is that what I know is that this is some angle, because when I plug a number into the inverse, it undoes the inverse and gives me an angle. So I'm just going to name it. How about I just name it theta? That's a good name for an angle. So I'll do that. And then I'll use the property of inverses to say what this actually means. So this means that when I plug in theta to cosine, I get 4/5 because they do opposites. Because inverses do the opposite. So I still don't know theta, but I do know cosine of theta. And what this means is I can use this to draw a triangle. So all we do next is we say, okay, well, if cosine of theta is 4/5, that means if I draw a nice little triangle here, and I pick theta somewhere, that means I know that the adjacent and the hypotenuse will be 4 and 5, and then I can figure this one out using the Pythagorean theorem. So then, how does that help me? Well, let's think about this thing again. So I wanted to know what this was. So I wanted to know sine of cosine inverse of 4/5. Well, what did I just do? I just said that the inside, I'm just going to change the name because it is just some angle. I just named it theta, so I'm just going to call it theta now because that's what I renamed it to be. And then what I can do is use that same triangle I just built and say, whoa, what is sine of theta? Because that's the same theta. Well, it's opposite over hypotenuse. So that's it. And then we're done. So that's the answer, is 3/5 there. So these are the more difficult types of problems. Let's do one more example. But they always work the same, luckily. So we can speed these steps up a bit. Step one is you take the inside and you just call it the angle that you don't know. But it is some angle, so you can name it theta. Then you use the inverse property, which is that if tan inverse of the number is that angle, that means that when you plug the angle into tangent, you must get that number. And then using that information, you can draw a triangle. So you can draw this triangle however you want, as long as you have a right angle and theta somewhere, and then you put the numbers in the correct spots after that. So this is opposite over adjacent. So this has to be 7, this has to be 4. And then I can use the Pythagorean theorem. So I can say 4 squared plus 7 squared equals the hypotenuse squared. So 16 plus 49, that baby is still crying. 16 plus 49 is, I think, what, 65? It's the hypotenuse squared, so square root of 65 is what goes here. This looks like a y, but that's a 4. Okay, so that goes there, and then what's the answer? Well, first I got to change the question. What am I really looking for now? I'm looking for sine of, and this whole inside thing is actually just theta. Okay, so that means I'm looking for sine of theta on this triangle. So what is sine of theta on this triangle? Opposite over hypotenuse. That's it. All right, so the last type of example is only slightly harder than that one. It's where you simplify something like this. It's almost the same question, same idea, but instead of having a number in inside the inverse, you have an x over something, so not just a number. But you do the same thing. So what does that mean? Well, I know that the inside, that should end up just being some angle theta, so I'm just going to call it theta because I'm doing the inverse of a number or an inverse of a thing with sine, so it should spit out an angle afterwards. Then I use the inverse property to tell me, okay, that means that sine of that angle must be that inside thing. And then I draw the triangle. And the triangle just seems like it might be different or something because it looks a little bit different, but it works the same, except I don't have both numbers. I just have opposite over hypotenuse as being x over 3. So I still just put x in the opposite and 3 in the hypotenuse, and it'll actually still work out. Because then, so let's see what this is. I'll just call it C. Actually, I shouldn't call it C. I'll call it B. So what's B? I can actually write it in terms of x. So here's how. Well, I know that b squared plus x squared equals 3 squared because of the Pythagorean theorem. So b is equal to 9 minus x squared. B squared is equal to 9 minus x squared. So b is the square root of 9 minus x squared. So that's what goes there. So I can simplify in the sense of this original question is actually asking me to figure out cosine of theta. And now I can say what cosine of theta is without any trig functions involved, because I know cosine of theta is adjacent over hypotenuse. And now I know what the adjacent one is without any trig involved. It's this thing. And then the hypotenuse was just 3. Okay. So those are all the types of examples. No daily problem today because I got a grade midterms anyway, so I don't feel like grading. But if you want more practice, then you should just start on the homework. So the homework will have questions of these types. Okay, that's it for today. See you next time.